Hey guys, today we're going to have some fun on a little bit of a side topic here. One of the questions that I get asked a lot from people following along with my Let's Make an MMO in UE4 series, which I have up here, and you can see we've got 43 videos in the series already. But one of the things that I get asked a lot is, why aren't you using a real MMO server? Why are you using UE4 as your back-end gameplay server? And so I think it would be kind of fun to do is let's build an MMO server, and so we can see some of the challenges, and we can talk about some of the reasons why we opted not to go that route. A quick disclaimer for all the haters out there who are angrily getting ready to comment on how stupid this is of creating your own MMO server. Let you know the purpose of this video is to point out not to do this. So I'm with you. I won't be approving any messages that are along those lines, so you can keep those to yourself. Okay, so first of all, what are we going to need? Okay, so the required software you're going to need to follow along is you're going to need Visual Studio 2017. I'm using 15.9.6, and we're running .NET Core 2.2. It may work in other versions. We're going to be using a benchmarking piece of software that has some certain dependencies. So if you try to run it on .NET Core 2.1 or the new Visual Studio 2019 with .NET Core 3, you might run into some trouble. Not sure. We're going to be using Unreal Engine 4.2.2. Any version should work. We're barely going to be using Unreal. It's not really going to factor into this much. Any version should work. I'm going to be using Fiddler 4 to do some testing. Postman will work as well. We're going to be building this in .NET Core. And you're probably thinking, .NET Core, MMO server? What are we doing? Well, .NET Core is actually extremely fast. It's not C++ socket server fast, but it's very quick. I have a study here done by an MMO called Age of Ascent. I believe it's a mobile space MMO. And they actually got .NET Core saturating a 10 gigabit connection with 7+ million requests per second. So it's fast, you know. It should be able to keep up. And so that's one of the reasons we're using it, because it's fast. Runs on Windows, Linux, and Mac OS. So from a cost standpoint, this is great. You know, we can develop it and test it on Windows and run it there, and then we can deploy on Linux for cheaper, hosting costs. So that's good too. It's also open source and free. So there's some great things too. The fact that it's open source has actually led to a lot of improvements in performance. .NET Core 1 to 2, and specifically 2.2 here that we're using, just massive increase in performance, many times over. And so those are some other reasons here. Okay, so let's close this. We're going to open up Visual Studio. Or create a new project. We're on .NET Core. We're going to choose an ASP.NET Core web application. And just so everybody knows, this isn't a real MMO server. We're going to call it Fake MMO Server. And we're going to hit OK. Okay, we're going to, we don't want to use HTTPS. It's going to give us some trouble when benchmarking. And we want to build an API. We're not going to build any authentication into this. We're taking a lot of shortcuts. Okay, so first of all, if you've never used .NET Core before, we have our startup. This is what's going to happen to configure our startup. We're going to make a few changes there. And we're going to end up creating a new controller. I don't want to use this values controller they have. And so we're going to create a new controller. This is what, I'll show you the controller real quick. This is what's going to get called, right? So you're going to call API / something, and you can post, you can get, you can do all these different things. You can add more methods as you want. We're going to create a new controller. And I'm going to call that controller. So we're going to right click here, add controller. And we're going to go with an API controller. We'll do read-write actions. We can repurpose one of those. And we're going to call this the player controller. Okay, and we're going to use this post. We're going to use this post here. So we're going to post to API player. And what we're going to be doing is we're going to be saving the location of our players from the client so that we can share them. And so to do that, what we need to do is we need to create a service that is going to handle our data. So let's go up here, and we're going to add a new folder, data, and we're going to create a player service. I'm going to add a new class. That's fine. Create a player service. It's going to be a singleton object that basically loads when the app load stays running. And we're going to use dependency injection. Okay. So what we need to do is we're going to need this service to inherit from an interface. And so let's build that interface. And this is needed for dependency injection. So we're going to add another class. I'm going to use the normal Microsoft way of putting an I in front of it. We called it iPlayer service. So the interface is going to define what methods that we're going to promise to implement. And so we're going to change this class to interface. And we're going to add a method. So we're going to add this method here called update player state. And we're going to send it a player name, and we're going to send it a reference to a player state object, but we don't have player state yet. So let's go create that. We're going to create a class. I'm going to call it player state. And we are going to add a few variables. Okay, so we've got our player name, we've got our location X, Y, Z in floats, and we've got our rotation X, rotation Y, and rotation Z. And now we can come back over here, and you see it resolved that issue. So now we can go back over to our player service, and we can we can implement our interface player service. And it's probably complaining that we did not implement what we promised to. Okay, that's good. We're going to do that. They got all these things in here to help you. This system makes it insanely easy. I always joke that the AI are going to take our programming jobs soon because it's too easy. Okay, so what we're going to do is first we need a data structure. Okay? And so we could use a dictionary, but we are going to be dealing with a high-speed multi-threaded application, and therefore we need a thread-safe dictionary, which is called concurrent dictionary. And I'll finish doing the rest of it here. We're going to want to use a string as the key, and we're going to send in player state as the type, and we're going to call this, using the common convention here, underscore players list. Okay, and it's all upset, but it's smart enough to tell us, hey, you need system collections concurrent. We'll say, okay, sounds good. And it would help if I could spell string right, and there we go. So it helps us implement that. We're going to need a default constructor. Player service. And in that constructor, we want to allocate memory for our players list. So here's players list, and we're saying, yeah, give me a new concurrent dictionary of that type. Okay, and then this interface is mad at us for not implementing what we said we would implement. I'm going to copy and paste this. Okay, so we promised that we would implement update player state and that this is what it would look like. Therefore, we are implementing it. You send in a player name, you send in a player state, and all we're doing is saying, hey, find that player name value in there and set it to this, which if it's not already there, it adds it. And then because this is a task, it's an asynchronous task, we're just saying task.fromResult, and we're just returning a 0. It's a common thing. You return -1 if there's an error, 0 if there's not. So we're doing that. Doesn't really matter. And okay, so now we got this player service, but we need to be able to use this player service in our player controller. And so what we want to do is we want to create a reference here, private iPlayer service, right? So this is our interface, which it doesn't know about, but we'll fix that. And we'll do player service. Okay, it doesn't know about the iPlayer service. We do show potential fixes. It knows we need to add our data namespace. And now it has it. So what we're also going to need is we're going to need a controller to handle our dependency injection. And what we want to do is we want to send in an iPlayer service. And we want to basically set this internal reference equal to what it sends in for injection. And that will make it available to us down here in our post. And so now in our post down here, we want to rewrite this a bit. So we want to use, one of the things that makes .NET super fast is asynchronous tasks. And so we're going to tell it that we will return an iAction result in our task, not tasks, in our post, and we don't want to send in a string. We actually want to send in a player state object. And I'll show in Fiddler in a minute here how this works. We're going to pull out the name. We wouldn't have to do this, just makes it a little easier, more readable. And it's mad, this post is mad because we're not, it'll tell us, hey, you had a task and you're not using await. So, but we will do that. We will use it right here. So we will do await. So this means stop and wait here until the result, right? Because it's asynchronous, meaning it's just going to hit the line and go on to the next line and not even wait for it to finish. But here we do want it to wait. We're going to use our player service to call update player state. We will send in this player name. And we will send a reference. This is just so, actually, it might not matter on this. I'd have to go double check. It might be sending a reference since it's an object anyway. Actually, I don't think it does. I think .NET Core by default would make a copy of the object. So it's going to be a little faster to send the ref. We'll do that. And then we just want to return OK. Now post is happy because we had an await. And the async iAction result's happy because we turned OK. This is 200, HTTP 200 message. And that looks pretty good. I want to check. Oh, there is a problem. We got this dependency injection here, but we don't have our dependency injection set up. So we want to go to our startup. And we need to set up the dependency injection. So right here in configure services, one of the really awesome things about .NET Core is it's completely modular. You can tell it, hey, I want this, I don't want that, and you can just add all these different pieces to it, make it as light or as complex as you want. It's really great. And it's also awesome that it has built-in dependency injection, which is a really cool thing. Okay, so we're going to tell it that we are sending iPlayer state as the interface. and that the type that we're going to be using is player service. And of course they're mad because my player state. Okay, hold on. We need, yeah, really? Player service, maybe this one will be smart enough. Yeah, there it is. We get lazy sometimes and don't want to do any of it on our own. I believe that add singleton, let's see what it needs here. It wasn't state, it was service. There we go. Now it's happy. Okay, so now what's basically happening is that it's creating this singleton, meaning it's only going to create one. When the app starts, anytime our player controller needs it, it's going to pass it into it. And because we're using thread-safe actions with our concurrent dictionary, shouldn't have any problems under high load. Okay, good, good, good. Could potentially turn off this MVC to gain a little performance, but okay. I think we're ready for our first test. So what we're going to do is we're going to put a breakpoint here on our post action. We're going to spin this up, and we're going to see what port it runs on. Okay, so we're running on 60129. Yours might be different. I'm going to copy and paste this. I'm going to minimize it. We're going to go over to Fiddler. And like, yep, I already had that. /, and if you look here, it's API/player. API/player. And it's a post, HTTP post, so we gotta change this to post. There's a couple things we're going to need here. We're going to need content type application/JSON. We may or may not need this, but we're telling it we accept application JSON back. It's actually not going to send anything back to us, but we'll fix that soon. It should be good. If we were doing some kind of authorization, we would also send in our authorization keys here, but we're not. We're skipping all that stuff. And now we get to this request body. And here's what we're going to try sending in. Okay, so that, remember, matched our player state here. Player name XYZ, RX, RYRZ, and in player controller we said that that was what we would send in from body. So now I should be able to post this, and we should get the values. I'm just going to just so they're not zeros, put some values in there. Look at that. Now we can hover over player state, and there we go. Capturing the right values. We can step through this. I'm hitting F10. I'm now going to, that was step over. I'm now going to hit step 11 to step into. And then now put it in the players list. And here we go. There's now an entry in our concurrent dictionary for Dart, and future ones will continue to update it. I can hit continue. We get back a 200, which is success, and if we double click on that, we can view the result, but it didn't send us anything back, it just sent 0, just empty. Nothing there. Okay, so that's good. That's good. We now have a basic server that we can call, and we can, and it's updating our state in this concurrent dictionary. Try to keep these videos shorter. It's going to be multi-part, but all of the parts are going to be done today and uploaded. So I think I'm going to stop this video here, and in the next part, which will be coming up soon, we are going to take a look at how we can benchmark this, right? We're really worried about speed. We could skip this step, but it's kind of cool, so I want to show it to you. How we can set up benchmark testing, and you can get an idea of how fast this runs. You will be surprised. So we will be back soon.